What's up guys, this is Massey. Welcome to another video. In this video I want to talk about Hess's law, and this is the second video on doing some examples regarding Hess's law. If you haven't watched the first part, please go back and watch that video first, and then you can start watching this video. So the first example I have here is B2H6 is a highly reactive hydride. Calculate delta H for the synthesis of diborane from its elements. According to the equation, 2B in solid phase plus 3H2 in gas phase is going to give us B2H6 in gas phase. Using the following data, 2B in solid phase plus 3/2 oxygen gives us B2O3 in solid form. This is a delta H. The second one is B2H6 plus 3O2 gives us B2O3 plus 3H2O in gas phase. H2 plus half of O2 is going to give us H2O in liquid. This is a delta H, and H2O in liquid is going to get to the water in gas phase. So we have in the ultimate equation, we need to have H2 and B2H6. It means that we need to get rid of O2. We need to get rid of B2O3. We need to get rid of O2 in here as well. And H2O in liquid phase and H2O in gas phase. So first thing, since we have B2H6 in the product side, we need to reverse the second reaction. So I'm gonna basically reverse everything. So that's gonna be B2O3 in solid phase plus 3H2O in gas phase is gonna give us B2H6 in gas phase plus 3O2 in gas phase. Delta H is gonna be positive 2035 kilojoule. The first one is going to remain as is for now, in case we need to go back and change it. Alright, look at here. We have H2 plus 1/2 O2 plus H2O liquid phase. We have 3/2 O2 in here, and we have 3 O2 in here, so we have 1.5 in here and 3 in here. We need to have another 1.5 in here as well. So I'm gonna multiply the third reaction C by 3. So it's gonna be 3H2 in gas phase plus 3/2 in oxygen gas phase, 3 liquid. So delta H is going to be 3 times 286, negative 286. That's going to be negative 858 kilojoule. And D here, since we have 3H2O in liquid phase, this one has to be in liquid phase as well. Delta H, 44 times 3 is going to be 132 kilojoule. Now let's see, here we have oxygen, and this oxygen cancel out. 3H2 cancelled out. 3H2 in gas phase, 3H2 in gas phase cancels out. B2O3. What else? That's it. So the rest is going to be the ultimate reaction in here. 2B plus 3H2O give us B2H6. Here we have the same thing. 2B plus 3H2 gives us B2H6. So delta H is going to be negative 1273 plus 2035 minus 858 plus 132. .36 kilojoule is going to be the final answer. So that's the enthalpy change of this ultimate or overall reaction in here. So this is the second example. It says the enthalpy of combustion of solid carbon to form carbon dioxide is negative 393.7 kilojoule per mole, and the enthalpy of combustion of carbon monoxide to form carbon dioxide is negative 283.3 kilojoule per mole CO. Use this data to calculate the delta H for the reaction of 2C plus O2 is going to give us 2CO. So the first reaction here is C plus O2, like half of O2 is going to be CO. This is carbon dioxide, so it has to be CO2. So this one is negative 393.7. The next one is CO plus half of O2 is going to give us CO2, negative 283.3 kilojoule per mole. So what can we do? We need to reverse one of them. I'm gonna reverse the second one, so make it CO2 gives us CO plus half of O2. Delta H is gonna be positive 283.3 kilojoule per mole. Then once you add first reaction with the second reaction, these two cancels out, and we're gonna have this half with one cancel, and we're gonna have only half on the reactant side. So C plus 1 over 2 O2 is gonna give us CO. So we need to add these two here. That's gonna give us 283.3 minus 393.7. It's going to be negative 110.4. If you multiply it by 2, 2C plus O2 is going to give us 2CO in gas phase. So delta H is going to be this number times 2, negative 220.8 kilojoule per mole. So that's the delta H of this reaction. 2C plus O2 gives us 2CO. That's exactly what we have in here. Next example, we have combustion reactions involve reacting a substance with oxygen. When compounds containing carbon and hydrogen are combusted, carbon dioxide and water are the products. Using the enthalpies of combustion for C4H4, which is negative 2341 kilojoule per mole, C4H8 negative 2755 kilojoule per mole, and H2 is negative 286 kilojoule per mole, calculate delta H for the following reaction. So the combustion of C4H4 is going to be CO2 plus H2O. We have 4 in here and we have 2 in here. So we have 8 and 10, 5 in here. That's going to be negative 2341. If you have C4H8 plus O2 is going to be CO2 plus H2O. We have 4 in here and we have 4 in here. So we have 8 plus 4, 12. You have 6 in here. So that's going to be negative 2755. H2 plus half of O2 is going to be H2O, which is negative 286. Now if I multiply the third reaction by 2, so it's going to be 2H2 plus O2 gives us 2H2O, and this number times 2, 286 times 2 is going to be negative 572. Alright, now let's see if we can add them all. The only thing we need to reverse it is the second reaction. It's going to be 4CO2 plus 4H2O gives us C4H8 plus 6O2. It's going to be positive 2755. Since we reversed the equation, the delta H is going to be reversed as well. The sign of it is going to be reversed. So now we have these two reactions and the first one. if we add them all, we have 4, 2, and 2 cancels out. We have CO2 and CO2 cancels out. 6 O2, O2 and 5 O2 cancels out, and we are gonna end up having 2H2 plus C4H4 is gonna give us C4H8. So delta H is gonna be negative 2341 minus 572 plus 2755. So that's negative 2341 minus 572 plus 2755. It's going to be negative 158 kilojoule per mole, and since it is negative, it is exothermic. So that's the enthalpy change of the ultimate reaction or overall reaction based on the thermochemical data of these 3 reactions. So, and the last example in this video is given the following data. We have 4 reactions here. C6H4OH2 gives us C6H4O2 plus H2, and this is the delta H. H2 plus O2 is going to give us H2O2, hydrogen peroxide. Delta H is negative 1991.2 kilojoule. H2 plus half of O2 is going to give us H2O gas phase. There's a delta H, H2 in gas phase gives us H2 in liquid phase, and it's going to be negative 43.8. So the overall reaction is C6H4O2 OH2 plus H2O2 gives us C6H4O2 plus 2H2O liquid. So what I'm going to do, I'm going to keep the first reaction as is. So C6H4OH2 gives us C6H4O2 plus H2. Delta H is 177.4. What else we need to do? We don't have hydrogen peroxide as well. We have it in here though, so it means that we need to reverse it. So I'm gonna make it H2O2 is gonna be the decomposition of H2O2. So we reverse the sign of the second reaction, so it's going to be plus 191.2, right? And what else? We have H2O in liquid phase. H2O in liquid phase here. This one is 2, so we need to multiply the fourth reaction by 2 for sure, in order to cancel with this guy. What about this guy here? Do we need to do that? Yeah, we need to multiply that one by 2 as well. So I'm gonna make the third reaction 2H2 plus 2 times half is just gonna be 1. It's gonna be 2H2O in gas. Delta H is gonna be 2 times 241.8 is going to be negative 483.6 kilojoule. And here we have 2H2O gas phase. It's going to give us 2H2O liquid phase, and I multiply this one by 2. 43.8 times 2 is going to be negative 87.6 kilojoule. So now we add them all. This one and this one cancels out. We have H2 and H2 cancels out. O2 and O2 cancels out. What else do we have? This one as well. H2 and H2, and here we have 2H2. So the remaining is going to be this one, as you see here. H2O2 on the reactant side, the products that we have this guy and we have this guy. So we need to add them all. It's going to be 177.4 plus 191.2, 483.6, 87.6 is going to be negative 202.6 is going to be the answer, kilojoule. That's the enthalpy change of the reaction. I hope you enjoyed this video. Please leave me a comment if you have any question and I get back to you as soon as possible. Please don't forget to subscribe to this channel. You can have other examples regarding chemistry, calculus, and physics. Thank you for watching and have a great day.